Oh, here we go. And we're live. Awesome! Hey Hacksters, welcome to Fundum Friday. And today I thought we'd do something a little bit fun. I know, because we never have fun. I'm Alex Glow with Hackster, and today I have a fairly old, actually, project from the Boldport Club, which is a PCB kit subscription service. They're all incredibly inventive and beautiful. Oh, let me grab the Monarch to show you. This is one that we did before. Ooh, and it's incredibly gorgeous. You might have seen me assemble this one before. And so if you're not familiar with Boldport Club, it's a subscription club, and you get access to a Slack full of awesome technical humans. You get one of these kits in the mail every month, and so that is my pick for today's Fundum Friday. And in celebration of that, I thought I would assemble one of the kits since I'm hella behind. I've got a few months worth of these kits that I haven't yet assembled, and this one is of particular interest right now because it is musical. And before I start with that, I want to show off a few other ones that I'm going to go into in depth in other days. One is the Fenderino. If you haven't seen the Fenderino before, it's an incredible little, look at this PCB. It's an Arduino shield made by David Quartielles, and it's open source, and you can find it online. A couple other cool musical boards. This one was sent out by Particle this holiday season. I gotta plug this in just so you can hear it because it's ridiculous. So it has like little lights that turn on and stuff, and you can, oh, maybe I've messed it up at some point. Oh no, here we go. Oh boy. Anyway, yeah. Yeah, that gets real old real quick. It's adorable though. And then finally this one from Open Hardware Summit last year, made by Tiny Circuits, I believe. Yeah. And it's a little piano that you can actually play. Oh yeah. And then you can have, if you touch the little switch here, it ingeniously switches octaves for you. Lots of cool stuff. Oh, and I always end up poking something that makes it play a tune, but I forget what that is. Okay, so this is a little sort of guitar thingy that you can put together. Let's take a look at the page for it real quick. If you go to boldport.com/product/stringy, you will find it, as well as, you know, all the previous kits up here as well. And this is a collaboration between Boldport and MadLab, who make tons of really inventive kits. There's a link to them, and you can see these kits that they have for everything from complete beginners to medium PCB kits to quite advanced ones, including little rocket ships and stuff. Super exciting. And this Atom Heart one, which I love, which is sort of like a an arc reactor from Iron Man, a perennially popular project. And their original version of this was called Funky Guitar. So the Boldport Stringy is an update to that. This is designed to be, pardon me, I might cough a little bit. It's designed to be used with a 9-volt battery, but you can also use a USB connector, micro USB connector, and I'm hoping that that's included so I can actually just run it that way because it makes me a little bit less nervous, I guess. The nervousness comes from all these warnings about not shorting out the contacts on the PCB with the metal body of the 9-volt battery that powers it. And so if you're a nervous Nelly like myself, you might want to go that way. But we'll see if that's actually included or not. Otherwise, I'll just find a 9-volt battery somewhere and make this make noise for you at the end. Couple extra things. There is a link as well to the GitHub page for this that includes a PDF with lots more information about it. Pardon. And also the GitHub, including all the files and stuff. And you can use Boldport's own custom built PCB editing software, PCB Mode or PCB Mod E, in order to edit the files and make it your own. Alright, so let's get started. I believe that this has a card inside of it that will tell me how to put it together. So let's try that. Switch my audio here. If there was any laggy audio, it's probably fixed now. But, ooh, I love unboxing, unbagging a new project. anything else in there? Yes. Ooh. So much stuff. Here's the PCB. Wow, that's gorgeous. Ooh. You've got your readily identifiable Boldport design here with the sort of organically flowing lines between all the contacts. That's beautiful. Anything else in here? Nope. Okay. Then we've got a bag full of components. I'm just going to dump those out. And a card on how to assemble it. Ooh. Oh my. Yeah, again, keep the battery body from touching the contacts. Ah, keep the contacts low. Cut in place under battery. They really don't want you to short this out. Cool. So they don't have like a physical layout that matches this. Or do they? Actually, is it the same? You've got your chip oriented kind of this way. Oh, that might actually be kind of a match. But I'm gonna have to do a little bit of like mental finagling to figure out which things go where. That's gonna be fine. Oh, great, and they labeled the values of the resistors and stuff. Okay, so they've got the components labeled on here, and their values labeled on here, so that's gonna be not too bad. Oh, amazing little pile of stuff. So I'm going to be soldering the socket for the IC onto the board and not the chip itself, because that's how you do it so that you don't destroy the chip with a bunch of heat from your soldering iron, which would be suboptimal. Interesting markings on here. So as usual, you've got pin 1 marked. Usually you have a little notch or a little dot over pin 1. And here you've got a couple of blue dots, which is interesting to me. I'm wondering if it like is a marking that they used to show that they'd programmed it or something. I'm not sure. Interesting. We've got a bunch of resistors of the same value. It's gonna be, yeah. Pardon me. Ugh. Those are gonna be our 1 kilo ohm ones, I think. Yeah, we got a ton of those. A couple of tactile switches. Oh, these are unusual. They only have 2 legs and they go straight down. Weird. You can see what a more normal one looks like if you check out my video from the other day about soldering together Oshwi, the PCB octopus. Somewhere over here. We've got our transistor. There's something called IC1, which indicates like it being a chip, and also a transistor that, according to the notes on the website, they look very similar, so we have to check the labels. I've never actually seen an IC packaged in this type of package, which is really interesting. So one of these is a transistor, one of these is more of like a chip. Weird. We got a couple capacitors, another capacitor, you got your battery contacts, super beefy. Audio jack, cool. Oh, so I'm gonna have to like plug this into an audio source, that's fine. This is just a length of wire that they've included so that you can space the battery away from the PCB. And then we've got a couple more resistors, a couple more little electrolytic capacitors. Cute. Or ceramic? Yeah. I always forget which term is which, but these are non-polar and these guys are polar. And then we have an LED. Rad! Well, let's get started. They don't give me like an order in which to solder things on. But we're going to be inserting things from this side and soldering them on this side, presumably. Because that's how it normally goes. Yeah. Cool. Oh, and all the little resistors are going to live in this sort of cool space here. Nice thing about resistors is they don't care which way they go. They're non-polar. All right, so I'm going to try and do like, I guess, a bunch of the resistors first. How many of those do we have? We have a ton of those. Bam! All right. So which are the weird resistors? That's the main thing to note here. I'm going to circle those. We've got R3 is 1 mega ohm. R5 is 47 ohms. Are all the rest 1 kilo ohm? I think so, because we've only got 2 of other values. So yeah, by deduction, that means that yes, all the rest of them are regular. Okay, so R3 and R5, where do those go? I'm going to put those in first. Those go here. Cool. So R3 is 1 mega ohm and R5 is 47 ohms. That means, okay, so this guy is going to be my 1 mega ohm, and this guy is going to be my 47 ohms. And I'm just sort of glancing at these to figure that out because, you know, I know that the 1 mega ohm is going to basically just have black and brown stripes, and the 47 one is going to have yellow and, what, green, purple? Yeah. It's the weird one. All right. So let's put those in first. I'm going to pull off the paper. I've got my soldering iron warmed up. And what I would do if I were a little bit more industrious is probably use one of those resistor bending things. They make these little, you can 3D print them actually. They're little sort of things with like a wide end and a narrow end. And basically you put your resistor on top and you can use the same notch to bend the legs down over it. So you get the same like width of resistor each time. And I usually just eyeball it, but that makes your life a lot easier if you're doing a ton of this stuff. So this is my 1 mega ohm one, and that's R3. Oh no, yeah, I misjudged that a little bit. Oh, go in there, do the thing. Ah, go. Grr. All right. And then R5 is my 47 ohm. Pardon. I've got this annoying cold that's been sticking around for like a couple of weeks now. So frustrating. And obviously the best way to cope with that is to do a bunch of soldering and put some fumes in my face. I should have a better fume evacuation device, but I don't have that set up yet. All right, let's solder these in. Yeah. Cool. Pretty simple. All right. Now for the rest of the resistors. Is there anything lower profile we're doing? I don't think so. I usually try and do the lowest profile components first because that makes life easiest. Gonna pull all of these off of their paper tape. Ah! They're going everywhere. Such is life. Yeah, so on this show before, I've assembled the Monarch from Boldport. That was that beautiful butterfly one that I showed you earlier. And they have a ton of other really cool PCBs that you can design. And some of them are kind of puzzles. There's like the cordwood ones, which are designed in this old style of putting together PCBs called cordwood assembly, where you have two PCBs and the components are in between them with one contact on each end. Super cool and really interesting to look at. I also did a show on specifically puzzle PCBs. There's a post on our blog about that. Our blog is blog.hackster.io, which is pretty obvious. But yeah. I'm gonna say my patter is probably not as exciting as usual today because I'm fighting my brain. Or rather my cough. These are pretty easy actually. I'm just bending them like right next to the resistor body. There's no like extra slack, so it's easy to figure out. Doop. So these are all 1 kilo ohm. SparkFun has a really cool puzzle PCB out as well. It's called the Harp, and I think, let's see, I think it stands for Hardware Augmented Reality Puzzle, but I could be wrong. I've been meaning to get a hold of that and like work my way through it. It's really, I've got a few hints, but I don't, like, fortunately I've forgotten most of the hints by now, because I kind of like the idea of just going in blind. But you might have to like decode chips or like solder some extra stuff on or whatever, or desolder things. Totally recommend checking that out if you like puzzles and or soldering and other types of electronic whatnottery, which I totally do. Cool. Oh, this must be where the micro USB connector goes. So that's not actually included in the kit, so I'm gonna end up grabbing a 9-volt battery somewhere. Got some interesting symbols over here for the battery. So you can see that like there's the little sort of INI bit that goes into the outie and vice versa over here for the positive side. And then also Stringy, a Boldport production based on the MATLAB design and the URL for the project. I love this. And this design actually echoes music as well, because if you take a certain wavelength of vibrating string and you divide it in half, so like if you put a finger down in the middle of the vibrating string and hold it in place, then you get 2 equal vibrating halves, and that will sound an octave higher than the original string if you give it the full length. And then likewise, if you, so this is like, you know, divided into 4 and you get 2 octaves higher. And then these are other intervals like fifths or whatever. I forget whether that's like a third or a fifth or what, but really interesting, cool sort of design that indicates something about what it's doing, but in a very artistic way. So let's do all the rest of these LED or resistors now. How wide is this? I'm gonna try going with that. No, that's probably too narrow. Oh, that's okay. Now, did they put the resistors in from the top or the bottom? From the top. Okay, cool. Pardon me. If anybody wants to send me like a lifetime supply of cough drops, that would be awesome. That's what a hardware lab really needs. I actually have some, but I'm not going to put another one in my face because I have lead on my fingers. You can use lead-free solder for soldering, but I usually find that it's harder to work with. And so I just deal with it. And obviously, if you're using leaded solder, then you want to wash your hands immediately once you're done soldering each time. And I'm just kind of bending the wires in their approximate equidistant from each side position. And it's looking pretty nice with the resistors getting all staggered like this. I really like this aesthetically. And I'm excited to have another PCB that makes music. I think the post on musical PCBs will probably go out next Tuesday. Yee! There we go. Oh yeah, if I wanted to be really like aesthetically consistent, I would make sure that the same band is on the right on each one, and it kind of looks like that's the case. I've got the thick brown band, which I think is the tolerance, yeah, on the far right. I actually made a song about resistor color values, but I'm not gonna sing it for y'all because I got a cold. Also because I don't think you would enjoy it very much. I don't know, who knows. But goes over tolerances and what the different bands mean and stuff. It's confusing sometimes because you can have resistors with anywhere from like 3 to 5 bands and probably more that I don't know about. Most common that I've seen is 4, but you know, in this case we've got 5. And you basically just gotta... Some people just ignore the bands and make sure that they have a really good filing system for resistors, which is another approach that's totally valid. But I like to be able to actually count them with the colors. I've done a video as well on telling the value of a capacitor. So these guys are labeled in a similar way to these. The 1 and then the 0 are like actual digits in the value, and then the 4 on the end is the number of zeros that you add, also known as multiplying it by 10 to the 4th. And yeah, that makes it a lot easier to actually read the value of the capacitor, which is not actually 104. Okay, one more. I got a little bit off center here, but that's okay. Probably has to do with how I'm inserting them as well. Oh, now the last one's kind of out of line. Okay. Even though the other ones are kind of off center, I'm going to make this one align a little bit better with those. Let's see, so this one needs to be a little shorter. The other one needs to be a little longer. We'll make it happen. How's that? Oh no, it's getting worse. I'm just gonna smash it down in there and hope for the best. It's fine. It's fine. Every person's kit is gonna come out a little bit different, which is part of the joy of it. There's a whole Slack channel that you can join if you're part of the Boldport club. Like if you subscribe and get the kit every month, you also become a part of this online community. This is so meditative for me. Except for the fact that I'm like talking to my computer. Hello, computer. So typically on Fridays, it being Fundum Friday, we will highlight a bunch of Kickstarters and Indiegogos and stuff for crowdfunding. But I just felt like switching it up a little bit this week because we adore Boldport and I've got such a backlog. And I'm actually looking at building a musical circuit myself, so I'm kind of like in this space of exploration and play. Let's cut all these guys off. I like to sort of hold them down so they don't fly everywhere. And cut them as close as possible to the PCB. Ah! Get out of there. Okay. Which I guess is also, yeah, what we've been told to do because of the risk of shorting. This is a little warm, but it's not too bad. Again, I'm going to wash my hands super intensely after this whole thing so that when I eat something next, it's not gonna get into my face. There are a number of different ways that lead can get into your body, but from what I understand, in regards to soldering, the most common is just for it to get on your food. Or, you know, if you bite your nails or whatever. Can't be too nervous as a soldering person. Alright, cool, check that out. Beautiful. Now we've got, maybe let's do the little capacitors and switches next. Pardon. Suboptimal. My cyborg chassis is not in top condition right now. So we've got what are these guys? 10 microfarads, 10 microfarads. What are those guys? That's C2 and C1. Okay. So 10 microfarads, 10 microfarads. And then this big guy is 220 microfarads. So I'm going to put just little like rectangles next to these guys to show that they're these big electrolytic ones. Here's C3. Okay, cool. That's going to be another big rectangle. So C4 and where are you? C5. Here. Okay. 0.1 microfarads. I think that's a micro symbol. Should be, yeah. So C4 and C5 are going to be these little guys. And where do you go? Where do you go? We've got the other three here. Oh, C4 is here. And I'm sure that it's really obvious. Oh, here. They're so tiny. Here and here. Okay, cool. I'm probably going to have to spread these a little bit, but not too much. So I'll leave a little bit of space. Actually, I'll just cut them off like the full way and solder them in. Then we can worry about trimming them. I hope y'all are all keeping healthy and happy. It's definitely a sort of starting to be allergy season for a lot of people. Fortunately, I don't have that issue, but something is stalking me. There we go. Get a little bit better light on there. This is probably a little wide again. Yeah, so it goes. I really want it to be as like close down as possible. But there's only so much that you can do. Okay. And maybe this is also why I'm building a musical circuit, is because I'm annoyed that this cold is preventing me from singing very well, and so it's nice to be able to make some kind of artistic noise. There we go. I'm going to check now and see if there's any questions, because sometimes we get those. Oh yeah, someone suggests wrapping the 9-volt battery in electrical tape before attaching it. I'm not actually able to scroll up, so if you said anything before that, then I can't see it, but let's just keep going. Alright, next up I'm going to do the switches. SW1 and SW2. After that, I think I'll do the socket. Although, no, I think I'll do the transistor T1 because that's sort of in between the socket and the resistors there. Alright, these two I'm assuming are identical. They come from the same tape. They should be identical. Cool. The project page has a guide to the interface and how these work together to produce different octaves and like a tune and other things that you can change. It's a little crooked. Can I fix that? Fix it. There we go. Keep banging my camera here, sorry about that. Boldport is located in London, and I went to interview Sarah Dreamer, who is the creator of most of these, and they have an awesome core of university students, and we actually did an interview that I've been really slow in publishing because I recorded about 3 hours of really fascinating dialogue, and I keep meaning to go back and transcribe it, but it's really slow going. But someday we will get to have that. At the time that we recorded it, he had about 450 subscribers, and they have, I believe, passed 500 now. I could be wrong. I think that's the case. All right. So we've got the 2 little buttons on there. Glorious. Let's do T1. So yeah, the little instructions, let's see. T1 is BC547B, and IC1 is 78L05. Okay, so this one is T1. It says B5478 P6E on it. Is that a 6? Yeah. So this is T1? Yeah. Just really want to make sure of that before I attach it. And then I'll do the IC socket, the 8-pin one. And then I will do IC1. And the nice thing about transistor outlines for this is that they just line up with the flat side and the dome side. You just stick it in. You almost never have to do any bending of legs for these because they're already set up just right on the footprint. Nice. Okay, cool. I do like to run things off of micro USB because I have a ton of 5-volt USB phone charger power banks. They do actually make rechargeable 9-volt batteries. You don't see them very much, but they do exist. So, you know, if you want to be a little bit more eco-friendly while assembling your Boldport kit, you can totally do that. I'm going to align, so the sockets as well as the chips usually have a little notch for when pin 1 goes. It doesn't actually make a difference in terms of the socket because they're just like direct contacts from the chip to the board, but it is very useful in remembering which way to stick the chip in, so here we go. Oh yes, they gave us one that just like kind of snaps in there a little bit, which means that, yeah, it'll stay in pretty well while I'm soldering. I don't have to like do any fancy hijinks to get it to stay in place. I am going to push it up a little bit from below. There we go. How's that? It's not quite flat. Oh, it is. It's pretty flat. I'll just do the diagonally opposite one and hold that in place. There we go. So basically I tack soldered pin 1 and pin 5 down first, and that sort of holds the whole socket in place so that I can solder the rest on. How's that look? Pretty nice. Oh, you know what? The first side is not super flush, so I'm just gonna sort of melt these down a little bit. Wow! Okay. Well, now it's flat. Good. Alright. Next, IC1, yeah. And again, double checking just to make sure that I did this the right way. And first, IC1 78L05. Yes, TSC 78L05, 6H1. 6. Yeah. I need glasses for far away stuff, but fortunately have not yet progressed to the point where I need reading glasses, which makes doing electronics a lot more fun than it would be otherwise. But, you know, that's why a third hand has like a magnifying glass on it. That's what this little spot is coming from on my table. Oh, that's a little dirty. Cool. Oh, where'd that go? I feel like a little piece of metal went somewhere. Oh no, it's just on the desk. Okay, cool. Got some sort of longish bits here, but I think they're fine. All right, so what's next? Little capacitors? Battery contacts, maybe? What do we got left? We've got the audio jack. We've got this LED. And the battery contacts and the capacitors. And then, of course, at the end, we have to stick the chip into the socket. All right, so I'm going to do the battery contacts because I think I have a chance of getting confused there. 9-volt battery. Never connect both battery and USB at once. That makes sense. It would be pretty disastrous. Well, you know what? Okay, V in means it's the positive side. And if I go find a battery, here we go. It's got a little bit of plastic wrap on it. It is easy to see that the positive side of the battery has this small male connector on it. And so that means I need to put the female connector on the plus side of the board. Ooh. Speaking of shorting, let's just throw that anywhere. Okay. Yeah, so this is going to go over here. Like so, I guess. Maybe I'll leave these for last. Because they're basically going to go in here. Like that. Cool. All right. The jack, the audio jack can go on either side of the board. I think I will do the capacitors and the LED. So LED 1, right? This line side here indicates the ground leg of the LED. You also have a square and a round hole. That also helps you understand that. And on the LED itself, you have a flat side, which corresponds to the short leg, which corresponds to ground. All these ways to detect which way it goes. And then if you did want to connect the micro USB, then there's a little jumper that you have to solder together. I think it's this thing here, VDD, VUSB. And that just, you put a little blob of solder across there. We're not going to do that though, because I don't have a random micro USB connector laying around in the lab. I am taking care to take a moment before snipping these off because I'm using my bare hands. I need it to cool for a second after applying the literally melting hot lead solder. The PCB already feels like it was already a little hefty, actually. There's a lot of metal in here, but it's definitely feeling more solid now. I'm gonna put the audio jack in on this side because I feel like it. Oh, the fact that it can go in on either side means that the two contacts are reversible, which is normally the case in audio, but huh. Interesting. Oh, I guess it's just monophonic anyway, so it doesn't really matter. All right. I'm going to do a quick tack soldering here. I'm going to do that by sort of bending up my solder so it sits on the table like a little snake and bending it down. Then I'm going to hold the component in place with my finger here and just bring it up to there. And that allows me, a simple two-handed human, to solder something that would maybe need to be held down to a table or something. Super easy. Someday I'll have multiple limbs. I mean, I have 4 right now, but that's not enough, is it? Never enough. Maybe the next Boldport kit will be some kind of like transhumanist augmentation. That'd be pretty cool. I will take some LED eyes, thanks, Sar. Yeah, that'd be great. I'm just making sure that there's plenty of solder on here. With an audio jack, these are not just electronic connections, but they're also physical connections, so I want them to be like nice and sturdy and solid. All right, let's do the capacitors next, I guess. Then it's just the battery connections left. So C3 is pretty obvious. They've marked the little positive leg there, which also has a square. With this capacitor, as usual, the short leg is the ground negative leg, but also you have a little stripe over here that shows that. Pardon. I'm gonna sleep so much this weekend, it's gonna be amazing. I hope you have some pretty cool plans, but if not, sleeping is always a badass thing to do. It's so good for you. There's a ton of cool sleep science coming out here, and also a lot of cool biohacking stuff relating to that. Of course, sometimes like the best solution is a non-technical one, but that doesn't mean people aren't gonna make really cool stuff with the aim of improving our lives. The 2 little capacitors are of course the same. And I'm just gonna check that I have everything oriented the correct way. The little plus signs are to the right here. The little stripes are to the left on all 3 of these. Awesome. Ooh! Tight quarters. I could use a finer tipped soldering iron. Or just, you know, you can replace the tip and get a finer one. Clean it off for now. Just so I don't have random globs of solder going wherever. That looks pretty decent. All right. We're so close! I can't wait to give this a try. I'll have to rig up some kind of an audio interface. Actually not sure what I have for that. I should just have like a Bluetooth speaker, but who knows? Okay, battery contacts time. Battery contacts o'clock. Oh yeah, and then there's these 2 holes down here where I'm going to stick that extra wire through to sort of prop up the battery. Let's do that first. One large piece of wire among many tiny pieces of wire, but it's not that hard to find. All right, it's kind of soft so I can bend it pretty easily. I'm just gonna give it a nice little sort of arc shape. About the same width as that. Maybe a little higher. Don't want any mishaps. They're very, very emphatic about that, so even if I weren't paranoid, I'd still be paying pretty close attention. All right. Yeah, it's not like the prettiest shape ever, but it'll do. Boldport also has a tendency to include designs that use certain parts of cut off legs from resistors and LEDs and stuff as connectors in his circuits, which I think is really cool, this sort of concept of reuse and recycling, and sort of basically the equivalent of like using every bit of the animal you kill, you know, but for electronics and vegetarians. Yeah, it's like you end up with all these little waste wire snippets, and you can still totally use them as connectors if you want. Obviously they're not insulated, but you know. I'm curious what this is. It doesn't really show anything. They've got little, oh, they're little musical notes, oh my god. But they also seem to be vias, like connecting one part of the board to another. Maybe not. Oh yeah, no, here, this pin goes to there, and then it gets connected somewhere, does it? It doesn't really. I think it's just like a cool little detail. I love this. One part of the interview with Sar, at one point he mentioned that he includes like little sort of wavy things and stuff, and people sometimes say that like, why do you have this extra stuff in your circuit, or why do you have these extra little like, you know, sort of aesthetic details? And he's like, well, usually the circuit doesn't need to be that precise. You know, unless you're making a really precisely tuned radio circuit, you usually don't have to worry about it actually being affected by some cool little aesthetic details, so why not? Why not make it look cool? And I'm going to double check again that the positive side, positive is male on the battery. Okay, so I want the female connector on here. All right. And these are pretty close together, so we do have to be very careful not to short them when I solder these on. I'm gonna, even though this isn't soldered yet, I just want to make sure that they're properly spaced so it'll actually plug in. Okay. Again, these are physical, like mechanical as well as electrical contacts. So I'm going to give them a lot of solder, make them pretty beefy. And I'm going to let the soldering iron dwell on there for a moment so that the solder really wicks down into the hole. Each battery connector is basically a giant heatsink, but it actually seems to be working pretty well. Yeah. Okay, let's check the other side. Yeah, that's pretty decent. There's a couple that could use a second more. I think these three here. I'm really making sure to contact both the leg of the battery holder and the through hole on the circuit board. That looks pretty good. All right, I'm gonna stick the chip in. Oh wait, I have one more resistor. What? What? But where does it go? It's another 10K one. It might just be an extra. Like sometimes you'll get an extra in a kit just because, you know, in case you drop one or whatever, it's not the end of the world. But why? Check it out, I've got all of these guys. In fact, those could maybe use a little bit extra soldering iron time. But yeah, then we got these guys. They're all there, except for the two that are weird. What is going on here? Oh yeah, there's a jumper for programming it with a pit kit as well. I don't see anywhere else that a resistor would go. So I guess it's fine. Cool. Yeah, we just have a spare. All right, so here is my chip, and what I'm gonna do is basically put it on the desk like this. If you notice, the legs are bent outward a little bit, and that's how they come in their rails. So I'm gonna just use my fingers to sort of bend it against the table so that those stick straight down. And a little bit. There we go. Okay. And I'm gonna have to find like some place to plug in an audio cable, I guess. But cool. And hopefully I haven't done something terrible or shorted something awfully or whatever to the point that it would hate me. Pardon. What if I just... I must have like a little speaker or something somewhere. Speakers. What if I tried to make it come out of this little piano? Let me try that. It's gonna be weird. Wait, I still have to have an audio cable. Well, do I though? Because... Okay, let me see the diagram of this jumper little jack guy. Ground is over here. And that's the this guy. Then you've got the little stereo guys, but you know that either one of those will work. I'm gonna try just soldering. This is gonna be weird. I'm gonna try and make it work. Got a couple little wires here that maybe I can. Oh, I turned my soldering iron off. So like, I'm thinking that if I just attach these little jumper wires to the contacts on the jack, then I can touch them to the piezo on here. And ideally, if it's like compatible voltage levels, then it will not completely destroy the speaker, and I will get to hear some cool stuff. There's a possibility for disaster. There's always a possibility for disaster, but we'll see. There shouldn't be that much power coming out of here anyway. Oh my, it's already 6:30. Okay. Okay. First, let's clear all the metal off of here just so that I don't randomly short anything. Let's turn the soldering iron off again. I never trust an engineer with like a clean desk. I've said it before and it will say it again. Okay, plus, good. Oh, we have LED action. Wait, it stopped. Okay, start it again. Maybe it just like starts and stops. I have successfully not shorted the battery. That's very nice. If I push those, that changes. Okay, cool. Now we're gonna try and make some noise. Really hope this works. Otherwise it'll be a little anticlimactic, won't it? Let's put this up here. I'm gonna try and hold I'm gonna try and hold the contacts in place with my fingers on my right hand and play with my left hand. This may just end up in tears and sorrow, We will see. Let's change the focus on this for you so you can actually see what I'm doing too. Ill-advised as it is. Okay. These are the, honestly though, these are the parts that I love. I'm gonna put the short one over here. The long one over here. Oh boy. Danger, danger. Okay. Wait, how do I actually play this? Do I just touch it with my fingers? Because if so, it's not working. Wait, ooh. I know. It's supposed to play a tune if you hold down both of these. Oh, it's making noise! Yeah, it's making teeny tiny noises! Okay, you can just... I'm just gonna take this off screen for a second so that I can hold it up to the mic and you can hear it. Oh, this is so adorable. I'm not sure whether you can actually hear that or not. There's a very simple little tune. Maybe I've got another, like, larger speaker somewhere. I'm gonna nose around for just a second to see if we can get, like, an actual... Oh, wait! Here's another one! Fenderino! Yes! All my, like, little friends from before are coming out to play. Okay. We've got a little bit larger over here. Okay, I'm gonna make the tune go again. Wait. Supposedly that's how you make noise. Okay, okay. Let's try it with the larger speaker. Ah! Huh, nothing. Maybe we need an amplifier. Nope. Okay, well, anyway, I'm going to try and bring in a speaker on Monday so that we can actually hear this in action. That's really exciting, though. I hope you could hear the, like, little tiny noise it was making a second ago through this piezo, because that's so cool. Ah. Yeah, it's not the most glamorous way to do this, or the most well-advised, but it works! That is the plus side. It totally works. It's kind of heavy with this 9-volt battery on here, and it was already a pretty hefty board, but it's super musical. So this thing has acoustic and electric guitar modes that you can switch between. I'm gonna give you a closer-up view of it. Yeah. And then it can also play tunes, as you saw a moment ago. Ideally, I hope you could hear that. I'm gonna take these wires off again, actually, because I don't think we need those. And it can also change octaves to be higher or lower. And those are basically the three things that your little buttons can do for you mode-wise. And then you have that little LED for feedback. There's no on-off switch. You basically just are supposed to connect and disconnect the battery, which makes me a little nervous, honestly, because this is a mechanical connection on the board. And I'm afraid that if I do this too much, then it's just gonna, like, break. But it wouldn't be too hard to implement an on-off switch, though. All I have to do is, like, you know... Oh, you know what I could do is, I have a bunch of 9-volt battery wire connections, and I could just stick a wire in each of these, and then have, you know, the little ones with the little bendy plastic bit, and then have the 9-volt battery be separate. I do appreciate the aesthetics of having it be all one piece, and there's a newer kit by Boldport as well called Pips that's like a 6-sided die that electronically rolls, and that also uses this aesthetic of the 9-volt battery being part of the circuit, and it's actually used to prop up the die. So I appreciate that, but at the same time it kind of makes me nervous to have these connections just kind of... Yeah, this is a lot of lever force, you know, on here. Super cool, though. It's really aesthetically pleasing. It's really fun to put together. It's all through-hole, so super easy soldering. And I hope that you have enjoyed helping me. Like, you've all been, like, very much moral support helping me put this together today. Have an awesome rest of your Friday. Have a great weekend. And we will see you on Monday. Ciao.